Right, here we are back at the workbench again. And the latest venture is this 1975 Fender Twin Reverb that arrived yesterday. And I'd done some work on this amp just over 3.5 years ago. Quite a few things, if I remember rightly. And it came back yesterday, and the chap said it was dead, not working at all. When I fired it up, it fired up and started running. Then I had the classic red plating syndrome on the output valves, as you'll notice if you look at the photo I took earlier on down below the previous comment. And I thought, oh, it's just drifted, because 3.5 years ago I'd done an upgrade on this, and with these, this big pot underneath this big one here, that's a balance pot for the output section, commonly called a hum balance pot. It's just like a jigsaw. It moves the power to one side or the other, one pair to another on the output tubes. It doesn't raise or lower overall, it just evens them out. But there's a mod you can do, and I'll show you on this one. I fitted this mod where I added a trim pot and a different resistor, and this allows you to raise or lower the overall current flowing through the output section. It increases or reduces the negative bias supply to pin 5. When I checked this out, there was no negative supply on pin 5 of these output valves. Nothing. So I thought, hello, we've got a problem here. So first of all, before I'd done what you see here, I checked the AC supply. There was 60 volts AC coming in here. This is a supply for the negative bias. It then runs through a resistor there, through a single diode, and it's rectified to DC. Then there's a cap, which is, you can see the new one here, I put on for testing. It goes to ground. Then the supply runs over to the other section over here I just told you about. When I checked it, I had the AC, 60 volts, but when I checked the diode, on the other side of the diode where this red lead is, there was no DC there whatsoever, nothing at all. So I thought, hello, maybe the diode's gone. But then I did a static test on the diode, and it tested okay, so I thought, must be another problem. So I then looked at this Mallory capacitor, which is the original one, what this has now replaced. Where is it? There it is. And I took it off and I tested it, and I'll show you. Yeah, so sorry about that, I lost the video. Anyway, this should be 80 microfarad 75 volt Mallory capacitor, and you see on this tester here. Just give it a few seconds. As you can see, it's nothing of the sort. Run it again. No, so it's defective. And when I tested it earlier on, it was just given 33 ohms resistance as well, so it's almost like a dead short. And that's why we lost the supply to the negative feedback circuit. So basically I just put a new capacitor on and just temporarily wired it in just to test it, as you can see. And now we've got DC minus 57 volts, which is perfect. And on the bias probe, we've got 43.8 milliamps, and with 355 volts plate dissipation, that brings that just a tad over 50%. And I can adjust it up and down. I find my little screwdriver, there it is, I'll show you. So this is the trimmer that I fitted, and you watch when I turn it. Higher, lower, see? It's now working absolutely perfect. Let's get down a bit. Just leave it there for a second. So everything is now working perfectly as it should. I may even replace this other Mallory cap that's in the circuit here before I finish it off, and I'm also going to solder this new cap in place where it should be and remove the test leads and everything. Now, it's surprising, but the output valves are still running, so what I'm going to do is I'm going to do an audio test on it afterwards, see if they're any good. If not, I should have to fit a replacement quad in there, which I've got, but obviously that'll bump the price up a little bit, but that's the way it goes. Yeah, so that was an interesting little repair. I was glad to say my work I'd done 3.5 years ago was not at fault, which is very pleasing. This is surprisingly quiet, this amplifier. Very quiet, very nice. Anyway, I'll see you later. Bye bye.